Okay, so we're going to start this lesson here. This is just a part 2 of the exercise 14b, counting ordered selection. So we're going to deal with restriction, okay? I'm going to give you questions where it's not really, in the textbook, in the Cambridge textbooks. I'm going to try a different type of questions there. The restriction question usually is it's a harder question, and the student you sometimes find it's a bit like hard to deal with. So I'm going to try as many questions as possible and try to offer you some of the ways to deal with the questions. Now, just keep in mind this. The method I use right now is the one I feel like confident of using it. There are certainly different methods of dealing with the different questions. If you have a better way of doing the question, definitely use your way to do it. Especially for the permutation combination type of question, they are going to have you are going to have those different ways to do questions. So I just sometimes I just feel like the method I'm using is a bit like sort of like suitable to me, to myself. You can have other ways to do it as well. Okay, so we're going to start with the question straight away. All right, so the first question here, the question asks you how many different arrangements of the letter from the word of mirror are possible if two vowels are next to each other. So I'm just going to write on the word we have. All right, so we've got the word mirror. All right, and then the first question here asks you how many different possible ways or arrangements if two vowels are next to each other. All right, so I'm just going to simplify the question, and I do understand, I think you guys understand what the question is about. So two vowels are next to each other. This is the first part of the question. All right, so how would you do this question here if two vowels are next to each other? So firstly, we need to identify the vowels, right? So I and O are the vowels here. All right, and then these two vowels must be next to each other. So there's a way we actually can do it. What we can do is we group them. All right, so like we just group I and O together as one group. Okay, this is just one group. And then we have our remaining letters, right? We've got the letter M, we've got letter N, and we've got letter R. So those are individual groups if you think about this, all right? Now, in total, we have 1, 2, 3, 4. 4 groups. So if we want to rearrange those 4 groups here, in total, we're going to have 4 factorial ways to rearrange it. All right, this is from the last lesson that you should know how to do it. 4 factorial way. But then also, please remember this, between I and O, you can actually switch the I and O around as well. So therefore, in this case here, in order for us to rearrange the I and O, there is a 2 factorial way of doing it, or just two ways of doing it. All right, so in total, in this case here, the question is just equals to 2 factorial times by 4 factorial. And you can actually use your calculator to work out the answer. All right, so the idea is actually pretty simple. You group these 2 letters as one single group because it says next to each other. And then what you do is you organize those 3. All right. There is another way you can do it. Okay, so alternatively, there's another. That's one thing, saying there's so many different ways, you can do with permutation combination question. Another way to do this is you rearrange these 3 first. Okay, these 3 letters first. Okay, taking these 3 as a group, you rearrange those. So if you rearrange those 3, that becomes 3 factorials. And then once you finish that, then you start to think about where do I put I and O. Now remember I and O, these are just a group. You can put I and O in 4 places, all right? That's the first place you can put I and O. That's the second place, third, and fourth. There are 4 places you can put it in I and O. So therefore you can times by 4. Okay, and then in between I and O, you can times by 2 factorial again because I can be the first letter or O can be the first letter. So that gives you actually the same answer here, all right? Because if you pay attention to that 3 factorial times by 4, it's exactly equals to 4 factorial. I'm just offering you a different way to think about the question. Okay, all right. So that is just the first part of the question here. All right, next. Next is to ask you how many different ways you can how many different arrangements of the letters of word mirror are possible if the first and last letters are consonant. Okay. All right, So that's the question here. If the first and last letter must be a consonant, all right, how many different possible ways are there? Now to do this question here, then we're using a completely different method, all right, or at least I'm using a different method to do this question. The way I'm going to do this now is by drawing boxes. So as you can see here, different questions sometimes requires us to use a different strategy to do it. All right, now the first and the last letter has to be a consonant, all right? So we just listed all the consonants, which is not a vowel. We've got M, we've got a N, we've got R. Those three are consonants. So therefore, all right, what we can do now is we can also have I and O to be the vowels, right? So now let's start. The first and the last letter has to be a consonant. So therefore, the first letter, you only can choose from three of them. So you've got, three choices. Okay, so therefore, for this one, you've got three choices. Now, for the last letter, you only have two choices, all right? If you have chosen one of the letter, you only have two letters left, all right? So you have two choices. Now, with the remaining letters here, it doesn't really matter anymore, okay? Because you can have a vowel or a consonant. It does not matter, all right? As long as the first and the last, that you only have like three or two choices, and then the remaining one is fine. So, think about it, all right? If we have already chosen two letters, we're going to have three letters left. So therefore, for this middle one, okay, you're going to have three possible ways to choose from three letters, and 2 and 1. Okay, so that would be the answer to do this question here. So at the end, if you want to look at the final answers here, the final answer is just equals to 3 times by 3 factorial times by 2, which is equal to 6 times by 3 factorial. And again, you can use your calculator to simplify and work out the answer. Okay, all right. So that's the first question here. This is about with restrictions. Okay, now obviously without restrictions, if there's nothing, you don't have to worry about any restriction. In that case, that the answer is just equals to 1, 2, 3, 4, 5 factorials way of rearranging the word mirror. Okay, now let's move on. Okay, so let's look at the next type of question. All right, so the next question is, in how many ways can 4 girls and 3 boys be arranged in a row? Okay, where the boys are always together, or where the boys and the girls are occupying alternate places. All right, so here we go. So we've got 4 girls. All right, and then we have 3 boys. Now the first question says, how many ways the boys are always together? Okay, so if the boys are always together, now the way to do this question is very similar to the previous question there, all right? Very, very similar. So we've got 3 boys, right? So let's just use different, shapes, diagrams, whatever, okay? 1, 2, 3, 4. All right, so we've got 3 boys and 4 girls. Now, 3 boys are always together, which means this is just a group. So in total, we have 1, 2, 3, 4, 5 groups. All right, so if we have 5 groups, and then if we want to rearrange them, that becomes 5 factorial. And then within this group here, these 3 boys can be rearranged again, so that becomes 3 factorials. And then if you multiply them together, that gives you the final answer. So this is pretty easy, very similar to the previous question we had. Okay. Now, the second question is the boys and the girls must be occupied in alternate place. So it has to be a boy, a girl, and boy like this. Okay, all right, so how do we do that? Okay, all right, so it has to be an alternate place. If you think about alternate place, position here, we have to have something like this. All right, have to have something like this. Unfortunately, because we have 1 less boy than girls, so therefore we can't have the boys to be the front, because otherwise, if that happens, you can't put this girl here. That's not in an alternate place. The only way you can put a girl is in the front. So that makes the boy has to be the second place. Okay, so how would you do this question? Well, it's actually pretty easy again. The way to do it is you talk about as a separate cases. So think about it, right? Between these 4 girls, this is girl number 1, number 2, number 3, number 4. these 4 girls can rearrange themselves, right, in 4 factorial ways. All right, so these 4 girls can be rearranged, all right, in 4 factorial way. And then after we finish the girl, then now look at these 3 boys. Now these 3 boys can rearrange themselves in 3 factorial ways. And in that case, there's only one position like it's possible, which is like a girl, boy, girl, boy. All right, that's the only position it's possible. So therefore, it's just 4 factorial times by 3 factorial. That's it. All right. If you do have like equal number of boys and girls, in that case it'll be 4 factorial times by 4 factorials, and then you need to times by 2 because you can have either a girl or a boy to be in the first place. All right. So that is the second question. Okay, all right. So I hope like this is a bit easier for everyone to understand. How do you deal with the restriction question? Usually the idea is you deal with the other condition first, all right, non-restriction part first, and then you deal with the restriction later. All right. So now the next question. We have the word pencil. Okay, pencils. All right, so the first question here is how many ways that letter E is next to letter I. All right, if letter E is next to the letter I, which means E and I must be joined together. Okay, so therefore these two must be grouped. Okay, all right, so again, similar to what we did before. All right, so these two must be in a group. We group E and I together. That's a group. And then we have a P and an N. We have C and an L and S. All right, so these are the groups. So now what we need to do is just count the number of groups. All right, so this is again very similar to the one we did before. So we've got 1, 2, 3, 4, 5, 6. That's 6 factorials. And then within this group, 2 groups here, all right, E and I, you can switch them around, and that's 2 factorials. So therefore the answer is 2 factorials times by 6 factorials. All right, so that's easy. Question B, what about E that comes before I? All right, now this is interesting. If E is before I, well, it didn't say anything about how many places that's before I. It could be one place that's before I, can be multiple places that before I. So the way to do it is you first forget about E and I, okay? This is very similar to the one I did last lesson, okay? So we list all the letters that's not E and I first. Within those 1, 2, 3, 4, 5 letters, we can rearrange those 5 letters around, right? So those 5 letters is 5 factorials. That's easy to do, to deal with. Then we're going to start to think about E comes before I. So we have multiple positions to place I. Okay, think about it. I can have an I here. Once I put I here, the E can be placed in multiple position. These are all the possible position for the for the E to be placed if I is the last letter. Okay, so we have like a 1, 2, 3, 4, 5, 6 different possible position. Okay, now we can definitely move this I over to that position there. So think about it, all right? Let me just move this I over. So if we move the I over here, if I is here now, then you only have 1, 2, 3, 4, 5. 5 position to have the E, all right? The last one disappeared. You can't have E to be on the right-hand side of I because E comes before I. All right, and then that means we now can still keep moving this I. Now the I is this point. All right, so if I is here, then we have 1, 2, 3, 4. 4 position for placing the E. So if we continue the process, we're going plus 2, plus 3, plus 2, plus 1. Because eventually you can actually have the I to be placed here. All right, if I is here, then you can't have E, you can't have E anywhere else apart from just one, position that's just before I. And that is just like a 1. All right, so therefore, that's what you are getting. So this representing the total possible ways to have E that comes to, that comes before I. So then the answer, the final answer will be just equals to, you do the calculation, 5 factorial times by 6 plus 5 plus 4 plus 3 plus 2 plus 1. All right, and it keeps going. I'll just use my calculator, and that just times by 21. All right, and you can use your calculator to work out what's 5 factorial times by 21. Okay, so these are the type of question with restrictions, and really hopefully that you find this is okay. It's not too difficult. I would like to do one last question. It is not really like in a restriction question, but it's like a sort of a proof question or show question. So you're going to show that NPR is equal to n minus 2 PR plus 2R times by n minus 2 P r minus 1 plus r minus 1 times by n minus 2 P r minus 2. All right. So I'm going to show this, okay? This is not really a restriction question, but this is a very, typical proof question with permutation. There will be a proof question for combination as well. All right, so how are we going to do it? We're going to start from the right-hand side, of course. You always start from something that's hard to do, okay? And for each of the terms here, we need to change that into the correct formula. So that becomes n minus 2 bracket factorial over n minus 2 minus r factorial. All right, and then plus 2r multiplied by n minus 2 factorial. So we'll keep going. N minus 2 minus r plus 1 factorial. Plus r minus 1 times by n minus 2 factorial over n minus 2 minus r plus 2 factorial. I'm just using the formula, okay? I feel like I'm probably just going to do it next page, so I've got more space. All right, so once we have finished this, all right, we just need to simplify each of the term. And minus, now with this one here, just be careful, with this one here, what I'm going to do is switch these two around, okay? So it's just a bit clear with the order of the numbers. So it's going to be n minus r minus 2 factorial. Plus 2r n minus 2, all right, and then we'll do the calculation for the denominator, so it's n minus r minus 1 factorial. So we're going to do something about, factorial unrolling as well, okay? So this is something that you learned from the first lesson. Okay, so that's n minus r and negative 2 and plus 2 cancels out. Okay, so that's what we get. Now, we need to make the same denominator. So this is a bit tricky now. With the same denominator, we need to look at which number is the biggest, okay? Clearly, n minus r is the bigger number, all right? It's bigger than n minus r minus 1. It's bigger than this. So what you need to think about is in order for us to actually change that denominator to n minus r, we need to times by n minus r. In order for us to change this one over to here, we need to times by n minus r minus 1. So therefore, if I want to change this term to that denominator, we need to times by n minus r minus 1 and n minus r to do it. All right, so that's what we need to do. Okay, so let's do a big fraction. Now, for the first one, I'm just going to highlight so it's easier for everyone to refer to. For the first one, I am going to change. So the denominator now is just n minus r factorial. However, for the first term, all right, the numerator, I need to multiply n minus r minus, I'm probably using a different color, so it's just clear. So I need to times by n minus r minus 1 and then n minus r. Okay, that just refer to that. For the second term here, what I need to times is the, so I'm just going to copy everything down first. Now I need to times by n minus r, okay? Because remember, if you times this term by n minus r, it gives you n minus r factorial. It's like if you times by 6 factorial by 7, you get 7 factorial, okay? Very similar, just opposite, to the unrolling the factorials. I would say rolling the factorials then. All right, so next, we don't need to do anything about it. All right. So the next step we need to do is we need to factorize. It does looks like it's a pretty crazy expression to factorize as a numerator. So factorize, we'll take n minus 2 factorial out. All right, and the denominator is still equals to n minus r factorial. All right, we don't really have any choice for the numerator, so what we need to do is just expand term by term, like just expanding here term by term, okay? All right, so let's just do it. Make sure you do it carefully so you don't make any silly algebra mistake. Otherwise, you know, there's no way you can get the final answer there. I'm pretty sure there's so many things you can cancel out, all right? So you get a very simple solution at the end. All right, I'm just going to highlight the things that we can cancel out, all right? So let's have a look. The positive r squared and positive r squared can cancel out with negative 2r squared. So this 2 is gone, all right? So these 3 terms is disappeared. Next, let's have a look. That's positive 2rn, that's negative rn, and that's negative rn. So these 3 cancels out. Okay, good. Now we can cancel out positive r with negative r, and that's also cancelled out as well. All right, great. So at the end, we only have n squared plus n out. Okay, so n squared is here, and plus n is there. All right. Almost done. Okay, over n minus r factorial. All right, so that gives you n minus 2. Factorize the second bracket. That gives you n minus, well, let's just do, did I make a mistake here? I think I made one little mistake somewhere. Yes, it should be a minus n. All right, if you check with this 2, if you times, it should be a minus n. So that's why I think it's not going to be right when I'm first checking it. Okay, so that's negative. All right, that looks much better. All right, let's just take n out, n minus 1. All right, and n minus r factorial. Now, if you pay attention to the numerator, n minus 2 factorial times by n minus 1 is n minus 1 factorial. And if you multiply by n again, that gives you n factorial. So overall, the numerator becomes n factorial over n minus r factorial, which is npr, and which is the left-hand side of what you need to prove, which is here. Okay? All right, so that's it. It's a very, very interesting question, and pretty much like in algebra, very high algebra demanding question here. So make sure you know how to do the rolling, factorials or rolling the factorials. Yeah, that's all. All right, thanks for everyone to watching this video, this lesson, and try to do a few, as much questions as possible with the restriction question. Now, remember, dealing with the restriction questions, there are so many ways you can do it. You can use my method of doing the questions, or you can find out if there's some easier way that you think it's easier to and suitable for you to do the question. All right, thank you.